Hello and welcome back, everyone, to this last session of Q&A for our Systems at Scale Winter Edition. I am Shilpa Lawande. I'll be your moderator for this Q&A session. So thank you to all the speakers who gave us these wonderful talks on performance and reliability at scale. We learned about Uber's next-gen infrastructure, Meta's warehouse data recovery, data warehouse recovery, disaster recovery, as well as mobile configuration at Meta, all very interesting and very different systems. So let's get started with our Q&A today. So Kurtis, let me start with you. What are some advantages and disadvantages of operating in the cloud versus on-prem?
Yeah, it's really interesting operating on these two very different kinds of platforms. On-prem, some of the advantages that we have is we actually have a lot of introspection into how the data center itself is laid out, and therefore we can know things like internal fault domains. So in all of our on-prem data centers, I know which rack every single host is in, and I can be intelligent about the way I schedule workloads such that I can help them avoid rack level failures. One of the major kind of disadvantages of operating on-prem is actually just acquiring the servers themselves, right? When you're purchasing actual physical hardware, you've got things like long lead times, having to negotiate not wanting to kind of get locked into a single hardware vendor, so needing to manage multiple vendors. And then kind of conversely, on the cloud side of things, capacity management's a little bit easier, by no means super easy. At the scale that we're working at, we actually have to have very close contact with our cloud partners and let them know what our kind of scaling schedule is going to look like. The cloud, as it turns out, is not as elastic as one might think when you start talking about, say, thousands of servers. So we do have to give them some kind of runway there. But then obviously, as long as we kind of give them good forecasts and give them, order of weeks heads up when, big new demands are coming in, they can usually meet those demands without much of an issue. So those are kind of some of the major things. I'd say the other thing with the cloud is maybe we kind of have access to a more diverse set of machine types. But then I would say the other disadvantages of working in the cloud is that to really take advantage of the cloud, you need to be able to operate in multiple geographic areas. And I kind of alluded to this in my talk. A lot of companies solve this problem by just saying they pick one region and they're like, yep, cool, that's the region we operate out of, and they try and scale just within that region. At Uber scale, that's becoming harder and harder for us to do. We need to figure out a way to be able to take advantage of what the cloud gives us in multiple different geographic areas.
Yeah, makes sense. I mean, many of these problems are similar to things we encounter at Meta as well. So switching to you, Michael, can you talk a little bit about your approach to mobile config canary? You mentioned a multi-prong approach of a shorter pre-land canary and then a longer, more in-depth post-land canary. Why do you do that? Why not just run the pre-land canary for a longer time?
Sorry about that. That's a great question. It really has to do with a trade-off between developer efficiency and trying to catch every single issue. So mobile config is so embedded in our developers' workflows that we want to make that process as quick as possible. So if we were to run a very long canary before we could make a configuration change, that might slow down developer efficiency. So by breaking it into a multi-stage approach, really get the best of both worlds. We're able to detect the most critical issues very quickly, and then we're able to, land the configuration change, and then watch it using that post-land canary to detect if there's any other issues.
Great, thank you. Abishek, question for you. How does the warehouse handle regional failures that are sub-region, when the whole region is not down?
Yeah, that's a good question, Shilpa. So essentially, when we plan our warehouse DI recovery, we look at the entire gamut of failures that can happen. We develop our services in a fault-tolerant way. So a large variety of faults can be handled within the region by the services themselves. But then we have policies on the extent of the fault and the kind of faults that are going to have a higher impact by trying to mitigate them within region. And based on those policies, we take decisions on when it makes sense to fail over and handle those sub-region failures through entire region being failed over. The ROI decision is based on how much time would it take for us to get back to normal operating conditions after failover versus how much time it would take for us to try and recover within the region. In addition to that, we also have strategies to account for additional capacity we need for regular maintenance so that we actually test sub-region faults as well. That complements our overall region level failover strategy. Back to you, Shilpa.
Sticking with region failures, then Rong, do you want to talk about multi-region failures? Like, what do we have a strategy for that?
Sure. Yeah, good question. As mentioned in the presentation, as our infra grows, the likelihood of multi-region outage increases, and we anticipate such failures to happen more frequent in the future. Our DR strategy is focused on two dimensions. The first dimension is data availability. Warehouse leverage additional data replicas, to improve the data availability. Try to reduce the probability of the data loss when disaster happens. Given that the capacity is bounded, warehouse would categorize the data and workloads based on the business impacts and allocate capacity accordingly. On the other dimension, the service availability, warehouse would apply site degradation strategies like service level degradation or delaying non-critical requests or workload jobs. This can help to free up some capacity that can be used as the complementary solutions for the DR physical buffer.
Got it. And just sticking with the failure topic a little bit, Kurtis, how does bad host detector scan your entire server fleet in 5 minutes? Sounds amazing.
Yeah, so the problem is actually IO bound. The first way we get these kinds of fast scans is, first of all, the thing to remember is that bad host detector is operating zonally. So I have one instance of the service operating for each zone. So immediately, the number of hosts that any instance of bad host detector needs to scan is only going to be like a certain partition of our fleet. But then really after that, it's just IO bound. So there is a single agent that's running on every single server in our fleet. This agent is installed on the golden image that I mentioned. And it just has an endpoint where we can scrape a bunch of hardware metrics. And so really the problem comes down to is how fast can BHD scrape metrics from each of the servers in our fleet? Because analyzing those metrics is actually like very straightforward. Most of what we call checkers are super simple. They're like, look at metric value, does it exceed threshold? And like, that's it. That's all we have to do. So the thing that the lead that I kind of buried in that slide about bad host detector is, yes, we have very fast scans. We're able to scan the entire fleet very quickly, but that's just our time to detection. The thing that actually matters to most of the teams at Uber is time to mitigation. Because if I leave a host that, say, has a bad NIC, or maybe just like a flappy NIC, running in production for, say, 30 minutes, that's 30 minutes of whatever workloads are running on that server having elevated error rates. And so a lot of what we're doing, the team that works on that particular component, a lot of what they're doing kind of going forward is looking into how do we actually reduce the time to mitigation, because that's what really matters for us.
Oh, great, thank you. Switching back to you, Michael, can you talk about a few examples of why we have multiple different ways to access the backend configs?
Yeah, absolutely. So there's actually a number of different use cases that this supports. a developer might want to run an A/B test, for example. So they can put in a configuration value, run an A/B test, and then decide whether or not they want to release that feature. And then without making any code changes at all client side, they can switch that back end to something like a gatekeeper or a rollout tool that will allow them to roll out that feature from, say, 0 to 100%. That's one of the use cases you might use that for.
Great. Just on the use case topic, Rong or Abishek, what is the DR strategy you have for ML workloads, and how is that different from other workloads in the warehouse?
Yeah, that actually is a very exciting area, Shilpa, and I would not go into too much detail, because of there's some things that we're working on in proprietary knowledge, but it is definitely a very major focus area for us right now. And I can talk about sort of the broad challenges that we see, which are new to ML workloads, which are sort of not something we've seen before. One is because of proliferation of prioritization of ML as a focus area, there's a lot of velocity in new hardware types coming up, and ML models are very sensitive to hardware types. When you train, if you change the hardware type, the sort of characteristics of that model change. So as much as possible, ML engineers, they want to train on consistent hardware types. And the way that creates a challenge is there's a lot of demand and a lot of diversity, right? We're sort of coming up with new hardware types every few months these days. How do we formulate a way in which DR can allow the right hardware types to be available for the right workloads, given the scale at which we operate and given the diversity? So that's challenge one. The second challenge that is very interesting for ML workloads is the most critical revenue powering workloads are also very sensitive to freshness, right? You want to close the loop between events happening all the way flowing through the system and the model getting trained on them so that we can respond based on the activities as fast as possible. And this becomes a very interesting challenge for DR, because now when we fail over, how can we design our failover strategy to ensure that the most critical models which require the freshest data actually have the ability to continue to operate when we have a region failover? So freshness and diversity and scale of capacity, these are the sort of two big areas based on which we are putting together our warehouse DR strategy for ML. Thanks.
Great, thank you. Speaking of challenges, Kurtis, would you like to tell us, what were the biggest challenges you ran into throughout this project?
I think the biggest challenges weren't necessarily technical. It was getting everybody to row in the same direction. Crane really cut across pretty much every single team that works in our infrastructure org. And so getting everybody aligned and on the same page and getting everybody to agree to what are the APIs going to be, what are the terms going to be, what are the SLAs going to be. That was probably the biggest challenge we had, especially because there were certain teams that were coming from very different kind of philosophical standpoints about how one goes about operating infrastructure. We had certain teams that were just very DevOps heavy, and the idea of doing a lot of automation and taking humans out of the loop actually was kind of scary isn't the right word, but it felt like a loss of control, and therefore we might cause more outages by not having humans in the loop. So getting everybody to kind of believe in the vision was probably the biggest challenge that we faced.
Great. There's actually a question for you from the audience that I will ask. Do you have any guidelines on estimating racking, stacking, infra, capacity management, cost estimation, and so on?
I play a lot of Dungeons and Dragons, and I like to make the joke that you approach a ambiguous conference room on floor 5 of your office building. You hear a bunch of yelling and shouting, and there's a sign over the top of the conference room that says capacity management, roll for initiative. It's really, really tough to predict this stuff because you have so many different people trying to trade horses and get the capacity that they need, all the while the business is putting the pressure on you of keeping costs in control. You can't just buy every single server that every single team wants. You need to make hard decisions and hard trade-offs. I don't work on the team that actually does the capacity forecasting, that does the server capacity forecasting, but I work closely with them because a lot of what we do involves making sure that the capacity that they get for us then ends up in the right hands. So I'm gonna like I don't want to misquote them or anything, but generally the way the process works is they look at past trends, right? And they make a prediction. There'll be like a graph of with a linear regression of, okay, if we keep scaling exactly the way we've been scaling for the last year or so, we'll do this. And then there's error bars on that of if we go 2x higher, we'll need this much. If we go 2x lower, we'll need this much. And they kind of try to thread the needle in that respect.
Cool. Yeah, it is a very challenging problem. We also experience this all the time at the scale of Meta. Michael, another question for you. You mentioned using a pull model to periodically refresh configs. Did you consider trade-offs with a push model instead?
Yeah, that's a great question. So the reason we use a pull model is all about really scalability. It's not super important that mobile config has the latest value instantly because we actually lock values per a given session. So even if we were to distribute the latest configuration values to all apps instantly, they won't actually be used until the application's restarted. So by using a pull model, we have a little bit more control, the traffic's a little bit more predictable, and we don't have to use up a ton of resources when we're actually doing our syncing. Gives us a little bit more flexibility there.
Great. Rong, another question for you. How do you measure PR readiness or user impact in the warehouse?
Sure, good question. To measure DR readiness or user impact, we follow the industry standards, RPO and RTO matrix. RPO represents the recovery point objective, which is the amount of data that can be lost before significant harm to the business occurs. The RTO means the recovery time objective, which is how much time the application can go down without causing significant damage to the business. Now, for warehouse, the RPO is defined as a freshness loss due to the replication latency that is mentioned in the presentation. About RTO, for interactive workloads, it is the delay introduced due to the disaster detection plus the failover process duration. For batch and ML workloads, it also includes the landing delay introduced due to disaster events.
Great. Okay. Well, I think we have a couple of minutes, so maybe I'll ask you all to talk about, what is one big lesson you've learned from building the systems that you talked about today. Let's start with you, Kurtis.
I think I'll just go back to kind of what I said in my presentation, which is that, in all the last years that I've been working on infrastructure, I've just really kind of come to very much appreciate the power of automation. It's automating things all the way, not getting 90%, and then there's one thing that has to go, and a human has to go click a box somewhere to say yes and approval. It's fully getting things completely automated. When you see that kind of a system work, that there's just no humans in the loop and it automatically heals itself whenever there's problems, it's so amazing. Right now, at anywhere in Uber, with maybe one or two exceptions, I can just go and rip the power cable from one of our racks, and nothing will happen because, of course, everything we run is generally run in a highly available fashion. But those servers will be detected automatically that they're now offline. They will be moved into a repair queue, and then immediately, within like 5 minutes, servers that are waiting in the wings that are on standby will be pushed into production, and new workloads will just automatically start running. I think it's some of maybe like the bigger companies, this is kind of old hat, and yeah, of course it works that way. It wasn't that way at Uber just a few years ago. And so to watch us go through that transition from, hey, we kind of need to handhold certain processes one way, or another, and to make sure that if something goes wrong, they come back in a healthy manner. To just, nope, there's no humans in the loop. Like in the middle of the night, some servers go down, nobody cares. There's nothing happening. It was just a really amazing transformation for me to watch.
And it frees up the engineers to work on more interesting things, right? Yeah.
Absolutely.
Yeah. Michael, how about you? What's your learning?
Yeah, I guess my big learning is just that mobile configuration done right really can drive developer efficiency. If you give developers all of the tools that they need to release software safely, like at a large scale, they're really capable of taking advantage of that and being extremely efficient. So I think that's my big learning.
Great. And last but not the least, Rong and Abishek, one or both of you want to chime in?
Yeah, I can take this. I think as Rong presented and similar to what Kurtis responded, I think the biggest lesson for us was the rigor of continuous testing for region loss is the most important thing. And we can talk about strategy and all those cool things we do, but it's really that continuous testing that we do that has revealed many surprising things where people have made assumptions about the services that we only discover when we actually do the testing. So to have like a good solid DR failover solution, the most important lesson is like regular and continuous testing across all your regions.
Right. So I heard good developer tools, good continuous testing practices, and automation everywhere. Right. So thank you for sharing those lessons. They apply to not just these, but many, many infra systems. So thank you again for joining us with the great presentations, as well as engaging on this Q&A conversation. And with that, I will hand back to Bahrain for closing comments.